Hi everyone. Tonight's lesson is going to be on how we study life, or the scientific method, which I know you've covered multiple times, really since elementary school. The key to scientific method is the back and forth between your hypothesis and the data that you get. This is really best exemplified in the lesson you had last year in chemistry, where you followed the development of the model of the atom. If we started with the model of the atom that Thomson had, was called the plum pudding model, you can see that it didn't have a nucleus and it had an overall positive charge with distributed negative charges. And the thing is, this was the best model at the time. But then along came Rutherford, who did his famous gold foil experiment. And that gold foil experiment gave him new data. And that data showed that there was something in the center of the atom with a lot of mass, which we now know, of course, to be the nucleus, where we have our protons and our neutrons. That new data led to the new model, the nuclear model of the atom. So the new data gave us a new hypothesis. In this case, the model is the hypothesis for this experiment. This model held for a long time until along came Niels Bohr, who was looking to explain how electrons behave when they absorb energy and then release that energy back again, and they release light. And the only way he could explain that was if electrons were in discrete energy levels away from the nucleus, and when they absorbed energy, they moved up to a higher energy level, and then when they came back down to their original energy level, they released that energy as light. And so that new data of how electrons can absorb and release energy led to the new model, or the Bohr model of the atom. Unfortunately, however, this model of the atom only made sense for hydrogen. Only hydrogen fit this model of the atom. So yet a new model had to go to fit the data for other atoms, other elements, and that is, of course, the quantum mechanical model of the atom, where the electrons aren't in discrete energy levels or orbits, but they're in orbitals or electron clouds in either the s orbital or the p orbital or the d orbitals. So what you can see is we had this back and forth between new data led to a new model, which was the hypothesis for what the atom looked like. So that back and forth between the hypothesis and data is the core of scientific method. So how do we define a hypothesis? It's an educated guess. It's a prediction of what you think will happen based on your prior experiment or results. Each of those previous models of the atom were based on the previous data. They were an educated guess for what the atom looked like based on what scientists knew at the time. Now, in order for a hypothesis to be considered a good hypothesis, it has to be testable. There must be able to be an experiment designed to test this hypothesis, and that experiment must be able to show in some way that it could be falsifiable. There has to be a way to test this and for it to be wrong. A good hypothesis also should lead to more hypotheses and more testing. If you do want to test your hypothesis, it involves many variables. And I know you've covered these before, but you should definitely have these definitions in your notes, and we will be talking about them more with example problems in class tomorrow. The independent variable. This is what you're testing. This is what varies. This is what changes in your experiment. The dependent variable is the data you're collecting, and that depends on your independent variable. Let's say I was running a test and I wanted to know, does more hours of sunlight or UV light make a plant grow taller? In that case, my independent variable would be the number of hours of light that the plant was getting exposed to. The dependent variable would be how tall is the plant. Now, if I do an experiment like that, where I'm testing the amount of sunlight on plant height, I would need to have some controlled variables. These are the things that don't change in your experiment. In order to get good data, you only need to have one thing that changes in your experiment. In our experiment with plant height, it would be the amount of sunlight. But other things that would be needed to be kept constant would be things like temperature, in the amount of water the plant was getting, in the amount of nutrients in the soil, maybe just the type of soil. All of those things would need to be controlled. They can't change, so that the only thing affecting the height is the independent variable, or the amount of sun that we're exposing our plants to. In most experiments, you're going to have both what's called an experimental group and a control group. Your experimental group are the individuals or subjects who are subjected to that independent variable, to that changing variable. So our experimental group in our plant experiment would be the ones that were getting different amounts of sunlight. Control group would be individuals who are not subjected to an independent variable. So in our plant experiment, we might have a group of plants who are simply given the sunlight that is available outside, so limited by the length of the day at that particular time. You must be able to know the difference between a controlled variable and a controlled group. Controlled variables are things that do not change in your experiment. The control group is a group that is not exposed to your independent variable. So you should have the definitions of all of these variables and the definition of a good hypothesis in your notes. And in class tomorrow, we will cover some examples of scientific method. So that's it for today.